It is the episode number 5 of the series Integration and Series. So today our problem is integration 0 to 1 ln x into ln of 1 minus x dx. If you want to try yourself, then please do pause the video here. And my suggested books are Problem Solving Strategy and Mathematical Circles for Olympiad purposes. Thank you. So before starting the solution, I am giving some hints for you. That first hint is ln of 1 minus x is equal to minus of summation n 1 to infinity x to the power n whole divided by n for all x greater than equal to minus 1 but less than 1. Second hint is that limit x tends to 0 x to the power n ln x equal to 0 for all n greater than equal to 1. N can be any real number in this case. So the third clue is integration 0 to 1 x to the power n dot ln x dx equal to minus 1 by n plus 1 whole square. Here is the proof that we are using bypass for the proof. So ln x part we are keeping intact first, and now we are integrating x to the power n part. So we are getting x to the power n plus 1 divided by n plus 1 from 0 to 1 minus 1 divided by n plus 1 integration 0 to 1 x to the power n dx. We have differentiated ln x, that is 1 by x, and 1 by x into x to the power n plus 1 becomes x to the power n. So final result becomes minus 1 divided by n plus 1 whole square. It is because that ln 1 is 0, and for the second limit x tends to 0 x to the power n ln x is 0, so the whole first part becomes 0. For the second part we are getting minus 1 divided by n plus n minus 1 divided by n plus n whole square. So we are trying that. The next clue is how we can write that 1 divided by n into n plus 1 whole square into partial fraction. So initially I have tried that we are taking common part 1 divided by n plus 1, then we are breaking that 1 divided by n into n plus 1. So it is very easy. We can write that 1 divided by n into n plus 1 in the form of 1 by n minus 1 by n plus 1. So in the first line we are doing that 1 divided by n plus 1 into 1 by n minus 1 by n plus 1. So now we are separating out that 1 by n into n plus 1. So from that we are getting 1 by n minus 1 by n plus 1 minus 1 by n plus n whole square. So it is very easy. Now you are pretty known to this vn minus 1 formula type summation, that summation n equal to 1 up to infinity 1 by n minus 1 by n plus 1, it becomes 1. It is very easy. If you write that summation n equal to 1 up to n, then the result becomes 1 minus 1 by n plus 1 and if you push n tends to infinity, then it becomes 1. And for the second part, we have to know this formula, that summation over n equal to 1 to infinity 1 by n square equal to pi square by 6. Now if we write that summation n equal to 1 to infinity 1 divided by n into n plus 1 whole square, it becomes that we can separate out by two known series which I have proved earlier in the previous two lines. So the summation becomes that 2 minus pi square by 6. In the second part, you must observe that 1 is missing, therefore we have to subtract from that pi square 6 minus 1, so it becomes 2 minus pi square by 6. Now let's come into the problem. Integration 0 to 1 ln x ln of 1 minus x dx equal to, we can write that ln of 1 minus x into some series formula, which is minus of 0 to 1 ln x summation of a from n1 to infinity x to the power n divided by n. So we can write that if we integrate first, then minus of summation n1 to infinity 1 by n into integration 0 to 1 x to the power n ln x dx. So we know that what is the result of the integration, that minus 1 by n plus 1 whole square. So our equation becomes summation over n1 to infinity 1 by n into n plus 1 whole square. So the result becomes 2 minus pi square by 6. Thanks for 9 plus subscribers. Stay healthy, stay safe, and stay tuned, and keep watching. And feel free to comment, share, like, whatever you wish, and subscribe my channel. Thank you.